Hello everyone, and welcome to the Regional Energy Efficiency Database, or REED. Today I will be going over how to use REED to analyze some data around how cost-effective programs are. This tutorial will focus on a question and conduct data analysis for that question. If you would like to learn more about how to navigate the REED spreadsheet, make a pivot table, and how to make a graph, please check out our previous blogs located on our REED webpage. Before I dive into the data, I'd like to give a little overview of REED. Every year, NEEP collects data from utilities across our region regarding energy efficiency programs. These data points include annual and lifetime energy savings, peak demand savings, avoided air emissions, and program expenditures. We are excited to share the new 2020 data with you all, so let's get started on some analysis. If you have the spreadsheet open, you will see that the first page contains general information about REED and important contact information down below. This is just the summary page. At the bottom here, you will see that there's another sheet titled 2011 to 2021 All Savings. This is the full database with all years available from 2011 to 2020 and a few data points from 2021 as well. Let's click on it to begin looking at the data. As you can see, this sheet contains a lot of information. Columns A through G contain information about states, programs, and utilities. Columns H through AH contain the numeric data with things like savings and expenditures. We also have these arrows that allow you to filter through the options. To make the pivot table, we will first need to select all the data. To do this, I will select the first row, scroll down, and the last one. Then I will insert pivot table and click OK. We now have another worksheet where we can create a pivot table to answer our question. Now let's determine the important information for answering our question. We will need to select program year, program sector, along with electric total program expenditures, and net annual energy savings at the electric meter level. We can separate these options into the correct categories, and some of them we just don't need anymore. For the values section, we want to make sure that we're looking at the sum and not the count. So I will change that to sum. Now we have a nice table that summarizes our data so we can answer our initial question. We will filter for 2020, and this will change the numbers down below. To do our analysis, we can copy and paste this table. Again, our question asked, in 2020, which program sector had the highest expenditures to achieve 1 megawatt-hours of savings? To do this analysis, we will need to divide our expenditures column by our net annual electric savings column. To get started, let's make a column to the right here, and we can label it expenditures over savings. Next, we can insert a simple formula that will allow us to do this analysis. If I click on this box and drag down below, it will copy the formula for the rest of the rows as well. These numbers show that the low-income program sector had the highest expenditures per 1 megawatt-hours of savings in 2020. The reason we may want to look at expenditures divided by energy savings is that it gives us a better idea of which program sector requires the largest amount of expenditures for the same amount of savings. By dividing by savings, we make it a common denominator, and that allows us to explain which program sector is the most cost-effective or the most costly for each megawatt hour. This may help program administrators when they are looking to target a certain sector and have a goal to achieve a set number of savings. If they can achieve those savings for a lower price by targeting a specific sector, then it's a win-win. If we look at our data on program sector here, we can see that the all programs category is the least costly for each megawatt hours of savings. All program sector pertains to programs that target residential, commercial and industrial, and low income. We can go back to our spreadsheet here and filter for these types of programs in the program sector column. To do this, I'll just scroll up, use the arrow, and filter for all. This gives us new data. It shows us a quick overview of these programs, and we can see that Connecticut has been doing a lot of these programs, along with Maine over the years. We also see that these programs tend to be mostly education or behavioral, and that makes sense with the all programs category, since the utility can widely spread education throughout different sectors without targeting a specific one. An example of the behaviors program is in Delaware and other states as well, where utilities send tips to lower energy usage with the customers' energy bills. It is low cost and targets the behaviors of multiple energy users at once, initiating an energy savings response. Now we can do the same type of analysis for program type as well. We can go back to our pivot table sheet, and instead of program sector, we can select program type. We'll overwrite the data in our table below. Next, we can again copy this table and paste it. Again, I will make another column with expenditures divided by savings. And drag that formula for all the different rows. Here, we can see the education is the most cost-effective for each megawatt hours of savings, while demand response is the costliest to achieve 1 megawatt hours of savings. If we go back to our data sheet and filter for education, we can see that one of the first programs is by Connecticut Light and Power, and it's called Educate the Workforce. After a quick Google search, we can find a description of this program in Connecticut Energy Efficiency and Demand Management Plan. The plan states that this program offers building training and sales training to professionals in energy efficiency. This read data can be helpful for energy efficiency decision makers. Program administrators and others can now see which program sector and program type is the cheapest to target for the same amount of savings. Additionally, they can search for examples of such programs to replicate by filtering through the main data spreadsheet. I hope you enjoyed this tutorial of the READ database and a first hands-on look at the new 2020 data.